This video is going to have us talk about population change. All right. So it's going to basically be the same as the other videos, but in the context of population. And we're just going to look at a homework problem and kind of apply what we've already done to the context of population. So we're looking at a small town in Ohio, and they commissioned an actuarial firm. There was a short amount of time where I considered being an actuary, and then I decided it was too much work. That is too boring. It pays a lot though, which is great. To conduct a study that modeled the rate of change of the town's population. So this study found that the town's population in thousands of years. Whoa, nope, that would be a long study. The study found that the town's population in thousands of people can be modeled by this function. Let's copy that down. P of t equals negative 1/3 t cubed plus 64t plus 3000. And I can't stress this enough. This is in thousands. That's not how you spell that word. So at the initial t equals 0. Wait, am I getting ahead of myself? I'm not. The initial population, when t equals 0, is not 3,000 people. Initially, there are 3 million people. 3,000 people. Wait, what? A small town in Ohio? What? I don't know much about Ohio, but it's 3 million. There's not even a city in Ohio with 3 million people, is there? What is this? The 3 million people isn't a small town? Am I losing my mind? P is in thousands of people. And it starts off at 3,000. P is 3,000, so that's 3 million. Wait, hold on. Biggest city, Ohio. Columbus, Ohio, maybe. No, population. I care about population, not size. Yeah, 3 million is a small town in Ohio. Come on, textbook. This textbook's lying to us. Let's. There's 3 million people. That's a real small town, Ohio. All right, textbook's not perfect, but it is free, and I do like that about that. All right, big fan. Whatever. A big town in Ohio. A big town in fake Ohio. Find the rate of change of the position function of the rate of change p prime of t of the population function. All right, well, that's no problem. The population of this crazy town, how it's changing is the derivative. Derivative is slope. Derivative is rate of change. So the derivative of this population, we use the power rule. It should be negative t squared, the 1/3 and the 3 cancel out, plus 64. And what are these units? This is in thousands of people per t is years. Yes, yes. So rate of change is a slope. Rate of change is something per something else. So this is going to be how the population changes in thousands of people every year. So specifically, initially when t is equal to 0, this small town has 3 million people, and it's growing by 64,000 people every year. That's what it wants us to do for part A. So find p prime of 1, p prime of 2. And we're not going to do all of these. Let's just do a couple. It'll illustrate the point. P prime of 1, p prime of 2. All you do is just plug it into the derivative function. All right. Plug in 1 here, you should get 63. Plug in 2 here, you should get 60. So this just says, you know, after 1 year, the city is growing by 63K people per year. And similarly, after 2 years, the city is growing by 60,000 people per year. So what's happening, right? This town is still growing. This small little Ohio town of 3 million people is still growing by tens of thousands of people every year, but the population growth is decreasing. It's not growing by as much every year. Soon it'll be a ghost town. Let's do part C. This is, I understand it. The population's decreasing. The population growth is decreasing. Maybe eventually the population growth becomes negative. This study was conducted a few years ago, and now it's a small town. There used to be, look it up, there used to be a bunch of towns in Ohio with more than 3 million people, but now they're smaller. Look it up. Look, learn your Ohio history, everyone. I'm sure that's what happened. Find P prime, double prime at 1, and P double prime at 2. Oh, we need to calculate the second derivative. Second derivative is just the derivative of the first derivative, which is negative 2t plus 0. So after 1 year, the second derivative is negative 2. After 2 years, the second derivative is negative 4. So it is what we're eventually going to call concave down. This means a positive derivative means the function is increasing. A negative second derivative means the rate is decreasing. So the rate is decreasing. That means 63K, 60K, it's going down. The growth is going down. Second derivative is the derivative of the derivative. It's the rate of change of the rate of change. Okay? This means after 1 year, the population growth is decreasing. Second derivative is the slope of the slope. Well, that's maybe not a great way to describe it. It's the rate of change of the rate of change. And specifically, it's decreasing by 2,000 people per year every year. Think of it kind of like acceleration. So it's growing, right? After 1 year, the population is growing by 63,000 people every year, approximately. But that rate is going down by 2,000 every year, about. So these are all approximate, right? This is all about estimating. We found that the actual change in growth was 3,000, a decrease of 3,000 people per year, every year. That was the actual difference in population growth. The second derivatives are really where things start to get a little squirrely conceptually. Just think about the second derivative as the rate of change of the rate of change. How is our rate of change changing? It's pretty hard. This is a good thing for us to have a conversation about or talk about it. It's a harder thing to just present in a video and be like, oh yeah, it all makes sense now, right? And similarly, after 2 years, the population growth is decreasing by 4,000 people per year every year. All right. And now that's the end of the problem. That's the end of the video. That's kind of what population growth looks like. How population growth is changing. That's our second derivative, kind of like our acceleration. Right? So even though this is really similar to the last video, right? Even though the population growth is positive, the town's getting bigger. Our small Ohio town is getting bigger, but it's slowing down. Positive velocity, negative acceleration in this case. Just like kind of the backwards of the last video. You want to think about this as a actual movement instead of a population equation. That's how you'd phrase it. Positive velocity, negative acceleration. The growth is slowing down. All right. Let me know if you have any questions, and good luck.